Hello, so welcome. Last week we talked about friction on a flat surface, like in this picture. The man is pushing the fridge on the ground, and we looked at the different forces which are on the object. Example, we have the force which is going to the right, and there is friction. There is also the weight of the object mg, and there is the normal force, and the normal force is perpendicular. This is perpendicular in Thai to the surface, and we said because the normal force and the weight are in opposite direction, they are equal and opposite. So normal force is equal to mg when we have a flat surface. But we know that in the real world, we push things not only on a flat surface, but on different surfaces, such as the skateboard, and also moving things into the track. So today we're going to look at friction on a ramp. We call this a ramp. Okay, it looks like that. It's a ramp. So if you look at this picture right here, when we leave an object like the ball on a ramp, sometimes the ball or the object will move down the ramp. What are the different forces on the object? So we're going to look at that with this example. We have a ramp which is at 30 degrees angle, and we have a box right here on the ramp. Let's look at the different forces. The first force you can look at is the weight mg, which is pointing down. There is the normal force, which again it is perpendicular. This is perpendicular in Thai to the surface. We also have the force which is moving the object down, and of course we have friction which is going opposite to the movement. Now, what is the normal force? On the flat surface, we said the normal force is equal to the mg, but this is not a flat surface. Now, if we could get a force which is opposite to the normal force, we could say that it is equal to the normal force. You can see here the mg, the weight, is not opposite to the normal force. So we cannot say that normal force is equal to mg. But if we could draw a force over here, we could say that this force, the orange one, is equal to the normal force. And in math, we can do that. So let's try and see how we can do that. Before then, let's draw and complete our triangle. And this angle here will be 90 degrees. It's a right angle triangle. And the angle over here is going to be the same angle right here, 30 degrees. So if this is 50 degrees, here will be 50 degrees too. Now, we have a ratio that we can use to find that. We call this side, we call them the sine, cosine, and tan. So if you do the math, this force here is going to be equal to mg cos 30, and this will be mg sine 30. So the normal force is equal to mg cos 30. We can say that because now this normal force and mg cos 30 are equal and opposite, so we can say that. Now if you look at this force, the force which is helping the object to move down, you can see that it has the same direction, and the same size with this force too. So we can also say that this force is equal to mg sine 30. Okay, so these are what the forces on the object when the object is on a ramp. Now here is a table to help you to find the value for the sine, the cosine, and also the tan. Okay, so you can see that example sine 30 is 1 over 2, sine 45 is root 2 over 2, and so on. You can look at this when you have to do some work with it. But let's look at one example together. So example 1, a 50 kilogram mass is moving down an inclined plane at 30 degrees angle. The coefficient of friction, kinetic friction, mu k, between the mass and the inclined plane, between the mass and this plane or the ramp, is 0.2. What is the acceleration? Okay, this is acceleration in Thai. What is the acceleration? We're going to look at this example together. So we're going to start by drawing all the forces on the object. So we have the weight mg going down, we have the normal force, we have the force which is helping the block or the object to move down, and we have friction going the opposite direction. We can complete our triangle. We know this angle is also 30, the same as this angle, and this side is mg cos 30, this is mg sine 30. And the normal force we said will be equal to this force mg cos 30, and this force right here which is helping it to move is equal to mg sine 30. So what is the acceleration? Okay, here is a formula to find that the net force, this is net force in Thai, is equal to mass times acceleration. So we have to find the net force. What is the net force? The net force will be this force right here minus the friction. Okay, if we can find the force here and we subtract or minus friction, we will find the net force. So let's look at that again. What is the friction? Oh, sorry, what is this force? The force here we said is mg sine 30. But what is the frictional force? There's a formula here. Friction is equal to mu times the normal force. So let's put it right in. Mu times the normal force is the friction force. And the normal force we said is mg cos 30. So mu times, this is the normal force, mg cos 30. If you put the numbers in, we have 50 kilograms times 9.8 g, which is 9.8 sine 30, minus the mu, 0.2 times 50 kilograms times 9.8 cos 30. If you do the math, we should have 245 minus 84, which is going to be 160.13 newtons. Therefore, acceleration is equal to net force over the mass. And if you put it in, the net force, which we just found, and then 50 kilograms. So our acceleration is going to be, so the acceleration is 3.2 meters per second squared. Now, for the next part of our class, this is the 3-level challenge. There are 3 different types of questions around the classroom. I want you to go to each level and answer one question. Level 1 is easy. The questions are a bit easy. Level 2 is medium. Level 3 is difficult. Good luck.